The lie you've believed your whole life. I want you to try something right now. Put your hand on a wooden table. Feel that? Feels room temperature, right? Maybe slightly warm. Now put your hand on something metal nearby. A spoon, a key, your phone case if it's metal. Feel that? Colder, right? The metal feels colder than the wood. But here's the thing. They're the same temperature. I'm not joking. If both objects have been sitting in the same room for hours, they are exactly the same temperature. Exactly. A thermometer would prove it. So why does metal feel colder? This is where your intuition starts to fall apart. And this is where the real physics begins. See, what you feel isn't temperature. What you feel is heat leaving your body. Your hand is warm about 98.6 degrees Fahrenheit. The table and the metal are cooler, maybe 70 degrees. So heat flows from your hand into both objects. But metal conducts heat much faster than wood. It pulls heat out of your hand more quickly, so your hand cools down faster when touching metal. And your brain interprets that rapid cooling as, this thing is colder. But it's not colder. It's the same temperature. You're just measuring heat transfer, not temperature. You following me? Your entire sense of hot and cold is a lie. Not a small lie. A fundamental misunderstanding of what you're actually experiencing. What temperature actually is. Now let me show you what temperature really measures. Because it's not what you think. Most people imagine heat as some kind of stuff. A fluid that flows from hot things to cold things. Pour hot water into cold water and the heat flows until everything's the same temperature. Simple. This idea is so intuitive that scientists believed it for centuries. They even gave this imaginary heat fluid a name, caloric. They thought hot objects contained more caloric, and it flowed like water from high to low. Wrong. Completely wrong. There is no heat fluid. There is no substance called heat that moves around. That's not what's happening at all. Here's what's actually happening. Everything around you is made of atoms. And those atoms are moving, constantly, vibrating, jiggling, bouncing around. Even in solid objects, the atoms are shaking in place. Temperature is a measure of how fast those atoms are moving. That's it. That's all temperature is. Hot coffee, the water molecules are bouncing around like crazy, smashing into each other at high speeds. Ice cube, the water molecules are barely vibrating, locked in a crystal structure, just trembling slightly. Your body. The atoms in your cells are moving at specific speeds that your biology requires. Too fast, you overheat. Too slow, hypothermia. Temperature isn't a thing. It's a description of motion. It's the average kinetic energy of atoms. Let me say that again because it's important. Temperature is atoms moving. That's all. Nothing more. Nothing less. The direction of energy. Now here's where it gets interesting. When you touch that metal spoon, what actually happens? Let me break it down. Your hand is made of atoms moving at a certain speed. The spoon is made of atoms moving at a slower speed. When they come into contact, the atoms at the surface start interacting. Your fast-moving hand atoms bump into the slower spoon atoms. What happens when a fast-moving ball hits a slow-moving ball? The fast one slows down. The slow one speeds up. Same thing with atoms. Your hand atoms slow down. The spoon atoms speed up. Energy transfers from your hand to the spoon. Your hand gets colder. The spoon gets warmer. Eventually, they reach the same temperature, meaning their atoms are moving at the same average speed. This is what we call heat transfer. But there's no substance flowing, just energy being exchanged through atomic collisions. See what's happening here? Heat isn't a thing. Heat is a process. It's energy in transit. It's atoms playing bumper cars at the molecular level. When physicists say heat flows from hot to cold, what they really mean is fast-moving atoms share their energy with slow-moving atoms until everyone's moving at the same speed. That's the beauty of it, something that seems mystical. Heat, warmth, cold is just tiny balls bouncing. Cold doesn't exist. Now wait. Let me tell you something that's going to sound crazy. Cold doesn't exist. I don't mean that as a metaphor. I mean cold literally does not exist as a physical phenomenon. Think about it. What is cold? It's the absence of heat. But what is heat? It's atomic motion. So cold is the absence of atomic motion. You can't add cold to something. You can only remove heat. When you put ice in your drink, the ice doesn't add coldness to your soda. Your soda adds heat to the ice. The energy flows from the drink to the ice, and the drink loses energy. It slows down, it gets colder. But nothing was added to make it cold. Something was removed. Energy was taken away. This is why absolute zero exists. It's the temperature at which atoms stop moving entirely. About -459.67 degrees Fahrenheit. -2,7,3,1,5 Celsius. 0 Kelvin. You can't go colder than that because there's no more motion to remove. You can't slow down something that's already stopped. Cold is just a word we use for less atomic motion. It's not a force. It's not a substance. It's not a thing. Hot exists. Cold is the absence of hot. I know that sounds philosophical, but it's physics. Real, measurable physics. Why this changes everything, here's what nobody tells you about temperature. It's not a property of objects. Not really. It's a property of atomic behavior. And that leads to some strange consequences. Let me give you an example. Take a match. Strike it. The flame is hot, maybe 1,000 degrees Celsius. Now think about sparks from a grinding wheel. Those sparks can be 2,000 degrees, twice as hot as the match flame. But if a spark lands on your skin, it doesn't burn you badly. If the match flame touches your skin for the same amount of time, you get a serious burn. Why? Because temperature isn't everything. The sparks are hotter, but they're tiny. They contain very few atoms. Even though those atoms are moving incredibly fast, there aren't enough of them to transfer much total energy to your skin. The match flame is cooler, but it contains billions more atoms. More atoms means more total energy, even if each individual atom has less. This is the difference between temperature and heat. Temperature is the average speed of atoms. Heat is the total energy of all the atoms combined. A bathtub of warm water contains more heat than a cup of boiling water, even though the boiling water has a higher temperature. More atoms, more total energy. You following me? Temperature is intensity. Heat is quantity. They're related, but they're not the same thing. The thermometer trick. Let me tell you about thermometers. Because they're doing something sneaky. When you put a thermometer under your tongue, you're not directly measuring the speed of atoms in your body. You can't do that with a glass tube full of mercury or alcohol. What actually happens is heat transfer. Your mouth transfers energy to the thermometer until they're the same temperature. The liquid inside expands as its atoms speed up, and you read the result. But here's the trick. The thermometer is measuring itself. It's telling you its own temperature after it has reached equilibrium with your body. Every temperature measurement is actually a measurement of equilibrium. You're never measuring the thing directly. You're measuring what happens when the thing shares energy with your measuring device. This sounds like a technicality, but it matters. It means temperature is always relative. It's always about the relationship between systems. There's no such thing as absolute temperature measurement. There's only energy exchange. The molecular lottery. Now this is where it gets really interesting. I told you temperature is the average speed of atoms. But not all atoms in an object move at the same speed. Not even close. In your cup of coffee, some water molecules are moving fast. Some are moving slow. Some are barely moving at all. Some are rocketing around like missiles. Temperature measures the average. But there's a whole distribution of speeds happening at once. This is called the Maxwell-Boltzmann distribution, named after James Clerk Maxwell and Ludwig Boltzmann, two brilliant physicists who figured this out in the 1800s. Here's why this matters. Even in cold water, some molecules are moving very fast. Even in ice, some molecules have enough energy to escape if they're near the surface. This is why ice cubes shrink in your freezer over time. It's called sublimation. The fastest molecules escape directly from solid to gas, even below freezing temperature. The average temperature says frozen, but individual molecules say, I'm getting out of here. Temperature is a statistical statement about a crowd. It tells you nothing about individuals. Negative temperature. When physics gets weird, I'll tell you something that sounds impossible. There are systems with negative absolute temperature, and they're hotter than anything with positive temperature. I know, that sounds insane. Let me explain. In certain quantum systems like lasers or specific arrangements of atomic spins, you can create a situation where most atoms are in high energy states, more atoms moving fast than moving slow. The distribution is inverted. When you try to assign a temperature to this, the math gives you a negative number. But negative temperature doesn't mean colder than absolute zero. It means the system is so far from normal that our regular temperature scale breaks down. And here's the weird part. If you put a negative temperature system next to a positive temperature system, heat flows from the negative to the positive. The negative temperature object acts hotter than infinitely hot. It's bizarre, it breaks intuition. But it's real. Scientists have created these conditions in laboratories. Temperature isn't a line from cold to hot. It's more complicated than that. At extreme quantum conditions, the whole concept starts to bend. What you're really feeling. Let me bring this back to you. To your body. To your experience. Right now, the atoms in your body are vibrating. Quadrillions of them. Moving at hundreds of meters per second. colliding with each other billions of times per second. That motion is your temperature. Your warmth isn't something you have. It's something your atoms are doing. When you feel cold, what you actually feel is your atoms slowing down as they lose energy to your environment. Your nervous system detects this rate of energy loss and interprets it as cold. When you feel warm, your atoms are maintaining their speed or gaining energy. Your body interprets stability as comfort. Your entire experience of temperature is your body monitoring atomic motion, not measuring it directly, sensing the change, feeling the flow. The cold wind on your face, it's carrying away your atoms' energy. The warm sun on your skin, it's photons crashing into your atoms, making them jiggle faster. You're experiencing atomic physics every second of your life. You just didn't know what you were experiencing. The beautiful truth, here's what I want you to take away from this. Temperature isn't magic. It isn't mysterious. It's atoms moving. Fast motion means hot. Slow motion means cold. No motion means absolute zero. Cold doesn't exist as a thing. It's the absence of heat, the absence of motion, the absence of energy. What you feel when you touch objects isn't their temperature. It's how fast they steal your energy. And every thermometer is a lie, not a malicious lie, just a simplification. It tells you about equilibrium, not about the raging chaos of atomic motion actually happening inside things. You know what I find beautiful about this? Right now, you're a collection of atoms vibrating at just the right speed for chemistry to work, for neurons to fire, for blood to flow, for you to exist. A little too fast, and proteins denature, enzymes stop working. You die. A little too slow, and reactions stop. Metabolism halts. You die. You exist in a narrow band of atomic motion, a tiny range of temperature where life is possible. And your body works constantly to keep those atoms moving at just the right speed. That's not just physics, that's you, fighting entropy every second of your existence, maintaining the motion that makes you alive. And that's not magic, that's physics. Beautiful, strange, wonderful physics.